Well, what we're going to look at today is trying to find the name of this quadratic sequence. So we're name finding. Now, in order to do that, I've got an example here that you can already look, and I find it really helpful to do this, to actually have sort of like construction lines. Just help me set things up nice and neatly, and I can put some more in later. So the sequence we're going to look for, and we're going to try and name this sequence, starts with a 4, and has a 13, a 26, a 43, and a 64. And we want to try and name this sequence. So to do that, first of all, I'm going to put in the order of the sequence. So I know that this is the first term is 4, second, third, etc. So they tell me that the first term is 4, the second term is 13. So this helps me with my structure. So whenever you do sequences, the first thing you need to really search for is, are there differences? Are there common differences? And so let's do that by taking away each value from the next one, and we call this our first difference. So let's just see what happens as we do that. Now, sometimes the numbers are really complicated and big, and you think, what do I do? Well, just use a calculator if you want. So from here to there, it's 9, then it's 13, and it's positive. So I'm going to put those ones in there because that's kind of important, especially when you do linear ones, actually. So that's the sequence, and you notice there aren't common differences. So what I need to do is I need to go down to another level. So I'm going away from a straight line now, so I'm looking to see if this is a quadratic. It's a quadratic if the second differences are constant. So let's look at the second difference and see that's plus 4, plus 4, plus 4. So we notice that now they've got a constant of plus 4. And because it's a second difference, there's something I need to remember. If it's a second difference, then I know that I halve the second difference as my coefficient here. Now let me explain what that means. Because I know it's a quadratic, I know it's going to be something to the power of 2. But I also know the coefficient, the number in front of that, is related to this. And it's always going to be half the second difference. So half of that is 2. So what I need to do now is I need to square these values and double them. So let's just do a little square, so I know it's 1, 4, 9, 16. I'm doing tiny little writing just to help me. So what I'm going to do now is I'm going to square those values. Double those values. So I get 2, 8, 18, 32, and 15. Sometimes you get a bit muddled, don't you? You think, what's happening? But there we go. That is my main structure for this sequence. So this is the main one, but it's not complete, because clearly if it was, that would be the same values, and they're not. So now what I've got to do is I've got to hunt for the second sequence within. So I've got to hunt for this second sequence. So it's going to produce another pattern, because what I want to do is, what do I add to 2 to get to 4? What do I add to 8 to get to 13? And you can see what I'm doing here. So to get from 2 to 4, I add 2. To get from 8 to 13, I add 5. To get from 18 to 26, I add 8. And I can see something happening here, which is really exciting. To get from there to there, I add 11. And I'm hoping if this goes up in 3s, that this is going to be 14. And yes, I add 14. So that's really good, because I can see a pattern happening. But can I name that pattern? That's the challenge. Can I name the fella? So, well, as always, I'm going to look for the differences. So here we go. And I'm going to look for the first difference and see what happens. And this goes up in 3s, up in 3s, and yes, awesome. Now the first difference, this is the first difference, which tells me it's linear, like a straight line, like steps, if you will. So I know that this is sequential, and it's called an arithmetic sequence. So I know the first value is 2, 5, 8, 11, and it goes up in threes, just like the 3 times table. The 3 times table goes up in threes, but it starts at 3, 6, 9, 12. So to adjust, what I do is I take away 1. That's my adjustment to make it fit this sequence, which so happens to be the same value that you get just in front here. What would be the 0 term here? If I went that way, take away 3, I would get my -1. So here, that's my linear sequence that fits with my quadratic. And these two combined together make that. So I'm going to combine them together, and I get my 2n squared. Then I get this, plus 3n minus 1. And I'm going to test to see if that works. So to do that, I'm going to just choose, say, the second term and put it into here and see if it works. 2 lots of 2 squared plus 3 lots of 2 minus 1. That's 4 times 2 is 8. 3 2s are 6 minus 1. So it's 8 plus 6 is 14. Take away 1 is 13. And that's what I want. Which tells me, fortunately, that this is the name of that sequence. I hope you found this helpful.